according to the Avogadro law. Now we apply the Avogadro law. What is the Avogadro law? Equal volumes of all gases contains equal number of molecules. Understand? Already the equal volumes of all gases contain the equal number of molecules. So let the number of molecules, one volume is equal to n number of volume. Okay, so mass of n molecules of the gas vapor at STP divided by mass of n molecules of the hydrogen. Okay, so already we are the now only we said mass of the volume of the gas is divided by mass of the volume of the hydrogen. Here, what molecules for the molecules, mass of the n molecules of the gas or vapor at density. Okay, mass divided by mass of the n molecules of the hydrogen. Okay, now the cancel in the n. N is the common. N is the common for that number of molecules, number of volume. Okay, so we derived that mass of 1 mole of a gas, n mole, instead of n we put 1. Okay, molecule of a gas or vapor at STP divided by mass of 1 molecules of hydrogen. Mass of 1 molecules of hydrogen. Okay, however, now this is derivation. This is over. What is that? First n molecule of gas and then n volume of gas combined with the mass of one volume, mass of one molecule, mass of one volume of the hydrogen, 1 mole of the 1 molecule of the hydrogen. Now we change that with the vapor density. Mass of n volume is changed into n 1 molecule of the gas or vapor divided by mass of 1 molecule of the hydrogen. Okay, now hydrogen is diatomic. Hydrogen, what is the molecular formula for hydrogen? H2. Molecule than a hydrogen. Only hydrogen atom means only one H. Here hydrogen molecule, so H2. How many atoms are present there? 2 atoms are present there. So hydrogen molecule is the diatomic. Hydrogen molecule is the diatomic. So mass of 1 molecule of gas or vapor at STP is divided by that mass of 1 molecule of the gas of vapor at density divided by mass of 2 atoms of hydrogen. 2 atoms of hydrogen. One molecule contains 2 atoms. So we change into that 2 atoms of hydrogen. Okay, when we compare the formula to the vapor density and the relative molecular mass, now we compared the formula. Okay, 2 atoms of hydrogen is compared with the molecular mass. Now, how we derive the equation? Mass of the 1 molecule of a gas or vapor at STP divided by 2 into mass of 1 atom of hydrogen. 2 into mass of 1 atom of hydrogen. Okay, this is the equation 1. Mass of 1 molecule of a gas. Mass of 1 molecule of a gas or vapor. Yeah, S divided by 2 into mass of 1 atom of the hydrogen. This is the equation 1. So, relative molecular mass, hydrogen scale. This is very important. Using hydrogen scale, relative molecular mass. How we derive the relative molecular mass? Mass of 1 molecule of a gas or vapor. Yeah, mass of 1 molecule of a gas or vapor is the ratio between the 1 molecule of the gas and the 1 atom of the hydrogen. Yes, mass of 1 atom of the hydrogen. This is the relative molecular mass. 1 atom of the hydrogen. We substitute that we substitute the equation 1 here. First, the mass of the relative atomic mass. Yeah, the mass of 1 molecule of gas or vapor at STP divided by mass of 1 atom of hydrogen is the derivation of the relative molecular mass. Okay, relative molecular mass is the derivation of the relative molecular mass. Okay, so we substitute this in the equivalent relative molecular mass divided by 2. Divided by 2. 2. 2 into mass of 1 atom of hydrogen. First, before that we arrange that. Okay, so vapor density is equal to relative molecular mass divided by 2. Yes. Next, Now on cross multiplication. Now on cross multiplication, 2 into vapor density. 2 into vapor density is equal to relative molecular mass. Relative molecular mass. Relative molecular mass. And then next relative molecular mass of the gas or relative molecular mass of the gas is equal to 2 into vapor density. Understand? This is the relation between the vapor density and the relative molecular mass. So the relative molecular mass is equal to the 2 into vapor density. This is the derivation. Yes. Now the lesson is over, mom. Okay. Next session, I start the next lesson. Now I repeat this.
நேற்று நைட்டு உங்களுக்கு 28 எடுத்துட்டு நான் பார்த்தீங்களா நேற்று நைட்டு 12 o'clock போல 28 பாட்டில் லாஸ்ட்டாக ட்ரிகர் பண்ணணும்.
Yes, relationship between vapor density and the relative molecular mass. Another one time, I repeat this. You learn. You hear this carefully, mom. Relative molecular mass. What is relative molecular mass? The relative molecular mass of a gas or vapor is the ratio between mass of the one molecule of the gas or vapor to mass of one atom of hydrogen. Mass of one atom of hydrogen. This is the relative molecular mass. Okay, ratio or that will be equal to the mass of one molecule of gas divided by mass of one atom of hydrogen. So this is represented as ratio. Understand? So the relative molecular mass of a gas or vapor is the ratio between the mass of one molecule of gas or vapor to mass of one atom of hydrogen. Yes. Next is vapor density. Next one is vapor density. What is vapor density? Vapor density is the ratio of the mass of certain volume of gas or vapor to the mass of equal volume of hydrogen. Okay, equal volume of hydrogen. So measured under some conditions, temperature and pressure. This is vapor density. This also ratio. This also ratio mass of the certain volume of the gas. Certain volume of the gas. Okay, that is first one is mass of the one molecule of the gas. Here one mass of one atom. Here certain volume of gas. We can take one or two. Okay, how many volumes of gas of vapor will be the mass of equal volume of the hydrogen. Okay, this is the vapor density. So now we derive this. What is vapor density? Vapor density is equal to mass of a given volume, certain volume. Here given volume. Okay, both are same only. Given volume of a gas or vapor at STP divided by mass of same volume of hydrogen. This is vapor density. Okay, now we related with that. Okay, what is the relation? According to the Avogadro's law. Avogadro law, what is called Avogadro law called that equal volume of all gases contain equal number of molecules. Equal number of molecules. Okay, so let the number of molecules as the yes. Okay. Thus, let the number of molecules in one volume is equal to n. Number of volume is equal to n. Okay, so vapor density n molecules of the gas. Number of molecules. First of all, vapor density derived as the certain volume, and then next next volume, and then equal volume. Next given volume. Certain volume, here given volume, and then here number of molecules. N molecules of a gas. Okay, n molecules of the gas or vapor at STP, n molecules of the hydrogen. Okay, so what do you know? What is the difference between this? Yes. Now cancelling n. N is the number of molecules. N is common number of molecules. So one molecule. We take the one molecule of gas. Okay, first of all, certain value vapor density derived for certain volume and then given volume and then number of molecules. Number of molecules, n is the n number of molecules. So we take for only one molecule. So mass of one molecule of the gas or vapor at STP divided by one molecule of the hydrogen. Understand? This is the vapor density. This is the vapor density. However, since hydrogen is diatomic, hydrogen is diatomic. So molecules of hydrogen in the molecule, how many atoms are present? Hydrogen atoms, two atoms are present. Two atoms are present. Understand? Two atoms are present means mass of one molecule of the hydrogen having two atoms of two atom of hydrogen. So the one molecule of the gas or vapor at STP is equal to mass of two atoms of hydrogen. Two atoms of hydrogen. Instead of one molecule, we write that two atoms. Yes. Now we compare the formula for vapor density. Now compare the formula with the relative molecular mass. What is the relative molecular mass? The ratio between the number of molecules with the hydrogen gas. Yeah. So here one mass of one molecule of a gas or vapor at STP, mass of two atoms of hydrogen represented one molecule of gas or vapor at STP divided by 2 into mass of one atom of hydrogen. We change it because the one mass of one atom of hydrogen, we have the two atoms of hydrogen changed into that mass of one atom of hydrogen into 2. Both are same only because now this is the equation 1. The derivation is the equation 1. Relative molecular mass. According to the hydrogen scale, the mass of one molecule of gas or vapor at STP is the relative molecular with the ratio with the hydrogen scale. Okay. So mass of one atom of hydrogen. Mass of one atom of hydrogen is the relative molecular mass. This equation is equal to the relative molecular mass. Understand? We understand this? What is the derivation? What is the first derivation? The ratio between the one molecule of the gas with the hydrogen atom. Same molecule of the hydrogen atom. Yeah. So one molecule of a gas or vapor at STP divided by mass of one atom of hydrogen. This is relative molecular mass. Okay, so this is the equation 2 we derived it. Now we substitute the equation 1. We substitute the equation 1. So relative molecular mass, we left one 2 into mass of one atom of hydrogen we have written. Okay, so the molecule of mass, one molecule of a gas divided by mass of the the molecule of the what is the equation? The molecule of one molecule of gas or vapor at STP into mass of one atom of hydrogen. This is the equation 1. We submit the relative molecular mass. How we submit the relative molecular mass? Mass of one molecule of the gas or vapor at STP 2. You left the 2. Mass of one atom of hydrogen is equal to the relative atomic mass without 2. So now we write relative molecular mass divided by 2. Relative molecular mass divided by 2. Vapor density is equal to relative molecular mass divided by 2. Okay, ba? Yes. Next, now on cross multiplication, 2 into vapor density. 2 into vapor density is equal to relative molecular mass of a gas. 2 into vapor density is equal to cross multiplication. Understand that 2 into vapor density is equal to relative molecular mass of the gas, or relative molecular mass is equal to 2 into vapor density. So now we derive the relationship between the vapor density and the relative molecular mass. This is one of the very important long answer. Mind it. If you are having any doubt, you ask through the WhatsApp. Okay, ma? Yes. Now, okay, ma'am. Now we repeat the percentage of, find out the mass of the percentage of the methane. Okay, percentage of the methane, percentage composition. What is percentage composition? The percentage composition means represents the mass of each element. Mass of the each element present in 100 gram of the compound. 100 gram of the compound. Okay, so in the hydrogen, nitrogen, so many gases are present in the atmosphere. Okay, so how many percentage of hydrogen is present means totally 100. In 100, how many percentage? How many? 16 percentage of hydrogen. Like that we calculated. Already we calculated in the last lesson, the atmosphere lesson. Okay, 78 percentage of nitrogen is present on the atmosphere. Okay, like that. Here also in the compound. Compound means hydrogen chloride. Hydrogen chloride is the compound. Water molecule is also the compound. Okay, that is in the compound. How many nitrogen present? How many percentage of nitrogen is present? How many nitrogens are present? How many percentage? That we represent in the percentage. Okay, next chlorine, like that. So percentage composition of the compound represents the mass of each element. Each element, each element means hydrogen and oxygen, nitrogen. These are element. But compound means hydrogen chloride, water molecule H2O. These are the molecule or the compound. Yes. Now, what is the formula for that? Mass of that element in the compound. Okay, mass of that element. Example for hydrogen. Hydrogen is the element is in water, H2O. H2O. Next, molar mass of the compound. Molar mass means we calculate the total mass of the compound. That is equal to the molar mass into 100. Give the percentage of composition. Yes. Now, the molar mass of the H2O is equal to 2. 2 means what? How many atoms are present? 2 atoms are present. Hydrogen atoms, 2 atoms are present. The number is, the atomic mass is 1. So 2 into 1, 2. Plus SD. Yes. Is this 16 is equal to 18 gram. Okay, mass percentage of hydrogen is 2 by 18 into 100 is equal to 11.11 percentage. 2 is the